So now we're looking at the watsonx AI services and how our end-to-end demos that we showcased earlier and the architectures are all connected in production-ready instances. At the top level, we're looking at the application layer. So this is watsonx Orchestrate in the case of the examples we showcased, but it also could be third-party applications. In Orchestrate, we have an AI assistant layer. This is AI-assisted experiences that are human-trained and designed. Next, we have skills. Think of these simply as business automation tools. They're intelligent task, decision, document, and workflow automations, and this is all augmented by generative AI. It's not just using the integration layer to connect to these different endpoints, but you also could leverage your out-of-the-box existing applications as endpoints. Next, we're going to jump into the actual AI services. So these are our agents. And to do so, we need to have our production-ready API endpoint. In watsonx Orchestrate, we're able to capture that endpoint when we're deploying the instance and then connect it to our various agents. In the AI service, we have 3 different agents that we highlighted earlier. 1 is the supervisor agent, 2 is the RAG service, and 3 is the SQL agent. The supervisor agent is routing between these different services, both assistants and agents, to maintain chats, tool calling, and organizing information for the end user. The RAG service is providing applicable recommendations for portfolio analysis and leveraging the conversational search functionality to leverage vectorized data and pull it into an end user output. Next is the SQL agent. This is going from a text to SQL framework, being able to pull prompt text data into an accurate SQL query. We're able to debug that agentically, whether that be using Orchestrate's agent capabilities or third-party frameworks like LangGraph, CrewAI to make sure we get the accurate structured data back in the actual interface layer. This is providing quantitative insights from the portfolio data in real time in our chat. I spent some time talking about qualitative insights and quantitative insights. Now I'm going to talk about where that's housed and how we're able to process the data so we have it in an end output in a chatbot. In the data layer, we have watsonx data, where we have vectorized data leveraged in Milvus. This Milvus data bucket and store has text data converted to vectorized formats that then can be used in a RAG pattern. For the structured and actual quantitative data, we have a Presto database leveraged. This is so that we're able to query against structured portfolio data. Other examples of data sets and sources that can be used is a PostgreSQL database or other open source or closed source databases integrated into the platform. Another option within the IBM platform is watsonx Discovery. We have out-of-the-box Elasticsearch conversational connections to vectorized data as well. So as an alternative to Milvus, some of the demos demonstrated earlier today leveraged Elasticsearch to pull in the actual text data to vector data. Lastly, there has to be cloud object storage. What I mean by that is the data needs to be hosted in a consistent place to be accessed for all of these different services from an AI and data processing perspective. In our case, we used IBM Cloud Object Storage, but we also can use AWS S3 Bucket, Azure Blob Storage, or other storage and database hosting examples that are approved within the Object Storage S3 landscape. So with this architecture that I showcased, financial analysts, investors are able to get their answers in a quick manner, whether that be on their phone, through the chatbot, their website, their computer, whether it be in a Teams meeting or Slack message. They're able to have various integrations to their business systems, connect, send emails, get PDFs, and trust the data in an enterprise-grade secure system. We are deploying AI agents that are trusted, flexible, and fast.